Another question that might be asked is to find a maximum or a minimum value, or it could be, you could ask for the highest value or the lowest value of a graph. So in this example, we're asked to find the maximum value of this equation. Right, again, a maximum is going to be a turning point because either side can't go any higher. So let's use our first derivative to find out our turning points. So 6 minus 2 times 3 is 6x, reduce power by 1. Remember, this equals 0 when it's a turning point. So we can have 6 equals 6x squared, divide both sides by 6. So 1 equals x squared, square root it, so x is either positive or negative 1. Okay, now we've got two values of x. There are turning points, or our stationary points. One could be a point of inflection, of course. Let's decide which one might be our maximum. So we're now going to find our second derivative. So differentiate this equation again. So you end up with minus 12x. Let's substitute in first positive 1. Give us minus 12 times 1, which is negative 12. So this tells us that our graph is turning negative. So the gradient is turning into a negative gradient around this point. So it was positive, then it's stopping at the stationary point and turning negative, which tells you that this is a maximum turning point. Let's just double check negative 1 just to make sure it's not also a turning point, not also a maximum. So let's substitute in negative 1. So minus 12 times negative 1, which is a positive 12. So at this point it is turning, the gradient is going to be turning positive. So to turn positive, so to go from going down to going up, this is our minimum turning point. So we now know where x equals 1 is our maximum value. It's the highest point of the graph. So at x equals 1 is our local maximum value. Because it's a quadratic, it either look like this or that, so the maximum will always not be the highest value, but it's simply the highest local value of x. So we can now substitute this value back into our original equation. So 3. So 1 is 6 times 1 minus 2 times 1 cubed plus 2, which is 6. Take 2 plus 2, which is just 6. So our local maximum turning point is 1, 6. Right. One last thing is a quick summary. Let's find the right sheet, there we go. So to summarise, a maximum turning point, a local maximum turning point is when our second derivative gives us a negative answer. That's because our graph was positive and it's turning into a negative 1 in terms of the gradient. Our point of inflection, so this was turning negative with the gradient. Point of inflection, our gradient is not turning positive or negative, it's just staying the same before and after our turning point. So a second derivative value of 0. if it is a positive second derivative, it means it's turning from negative, turning into positive, and because it's turning positive, it is a minimum turning point. That is basically it. I should probably just add in, sometimes you might get an equation and find out that the second derivative could just be 6, for example. So that might be a 6x plus 1. This could have been along the lines of 3x squared. So you differentiate it once, do it again, and you end up with some number by itself. Not to worry. So you'd have found that equals 0. You'd have found a value of x is negative a sixth. The fact you can't substitute this into this equation isn't a problem. This function is just telling you that the value found here must be a minimum turning point because this is a positive value, so it's turning positive. If it ended up with a negative value here, it's telling you this is your maximum turning point. Because don't worry too much if you can't substitute x into something. You just use a number that you're left with to decide whether this was a maximum, a minimum, or a point of inflection. And now, that really is the whole summary.